Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and encouragement of creating these kinds of technical videos. Today's topic of interest is Cad Cam. Generally speaking, Cad Cam means computer aided design and computer aided manufacturing. So, in design aspect as well as the manufacturing aspect, the association of computer is being postulated in the CAD and CAM. We can interface the CAD as well as the CAM by means of a neutral server or neutral format. We can integrate both CAD as well as the CAM. So this Cad Cam is an concurrent engineering process. What I am saying, the concurrent engineering process. In olden days, if you see, for a new product, they will do first a market survey. After that, they will do the feasibility survey, and they will do for each and every product. I am saying market survey, feasibility survey, and design aspect, manufacturing aspect, sales and service. So this take a huge amount of time. So this is called time. It take a huge amount of time for doing a product. But nowadays, if we take this much of time, our competitor will overtake us. Therefore, we have to integrate several things. This in order to reduce this time. So here concurrent engineering is coming to picture. First, they will do market survey. Simultaneously, they will do the feasibility survey, and simultaneously they have do the design aspect and manufacturing aspect, sales and service. Therefore, the time is very much reduced. So this much amount of time is being saved for the other purpose. So in this time, the saved time, we can produce another product which leads our industry or our concern in a topmost level. Like that, in the every company and every industry, it is working on this concurrent engineering aspect. Whenever the industry working on concurrent engineering, we have to interface this CAD as well as the CAM. So here the huge amount of datas are playing. Therefore, in order to store and in order to process the data, we need a computer, a supercomputer. So that is why it is called as computer aided drafting and a computer aided designing and computer aided manufacturing. So with these informations, I would like to go into the topic. Today's lecture, I am going to cover what is meant by a conventional machine, NC machine, CNC, and DNCs, adaptive control systems, machining centers, computer aided design, product life cycle, and 2D transformations, computer graphics, uh, and some of the 2D transformations, homogeneous coordinates, solid modeling, and the important curves, splines as well as the Bezier curves, and G codes, M codes, jigs and fixtures. These are all the things we are going to discuss. So, it is a huge topic. I hope that you have enjoyed the topic. So, first thing, the lathe. It is the mother of all conventional machines. So basically, lathe is mother of all machines. From the lathe only, the different types of machines are being getting. So it is a simple conventional machine, a lathe. Here, all the components, all the machining operations are controlled by means of a manual. That is why it is called as a conventional machine tool. So all the things are being in conventional. Whereas here the next machine is an NC machine. Here the NC machine means numerical control machine. Therefore, some of the process are being automated, or NC means semi-automatic. So here we are having a control unit and card reader is there. It will control, it will instruct, it will give an open instruction to the machine tool. There is no feedback from the machine tool is being drawn or analyzed by this numerical control. So this control unit, we are posting the codes. According to the codes it will be functioning, that is all. The next one is a CNC machine tool. Here, a small computer have been integrated with the machine tool, and this computer will control all the inputs as well as the outputs and feedback. In CNC machine, we can measure the dimensions, we can machine the dimensions. We have using some of the softwares and some of the codes for machining, and as well as the codes can be saved, or codes can be uh, stored in the memory. Some of the memory in inbuilt machine itself, we can use the code whenever we need. And also the editing of the code is also possible. So that is why it is called as a computer numerical control. A computer is installed in numerical control machine in order to convert the disadvantages of the NC to advantages of the CNC. Next is a direct numerical control, that is called DNCs. Here in CNC, only one computer controls one machine. Here, the several machines are controlled by a single computer. Even though the machine is having a small computer, but the code conversions, code creations, and feedbacks and other data are being stored in this supercomputer. So a single supercomputer will control a several machines, that is called as a direct numerical control, or DNC we can say. So with this information I would like to start my notes on NC machines. NC machine, an automation of medium and small volume production, can be called as an NC machine. The operator is replaced by system control unit and data process part. So data process part is called DPP. So operator is replaced by system control and data process part. The information or recording the component on the tape by means of teleprint or tape or punch card we can say. By means of a punch card only, the instruction have been given to the NC machine. Next is the classification of NC machine. First, according to type of motion, point to point motion. That is a better example for the point to point motion is the drilling machine operation. And straight line system, it is for stepper turning or pocket milling. Contouring or continuous system, that is machining of profile contours, can be done. If a milling machine is doing some of the profiles is called a contouring process. Next, according to the programming method, one is absolute coordinate. Absolute coordinate means based on origin 0 point it can be gone, and next one is an incremental position. So moving origin method, the origin is being moved, or it can also called as an incremental positioning or relative coordinate system or chain positioning system. For this, I would like to give a graph for your better understanding. If I am in absolute coordinate system, so this is my 0 comma 0. If I want to move from here to here, so this point I can say, so 10 comma 0. So this is x and this is y. So this is x and y. So 10 comma 0. And next, if I want to move here, this is 10 comma 10, and I want to move here, it is 0 comma 10. So like that the tool path can be moved. So this is the absolute coordinate system, whereas the incremental coordinate system will come like this. If this is my origin 0 comma 0, if I want to move this point to this point, and it will as a 10 comma 0, and here to here if I want to move, this 10 comma 0 will become 0 comma 0 again, and here if I want to move in a straight line, 0 comma 10 is my position. So here the toolpath is come like this. If I want to move in this direction, I have to give this point as a 0 comma minus 10, then only this origin will come into here. So like this the incremental point have been given. So this is called as a incremental positioning or relative coordinate system or chain positioning method. Okay, I hope you have understand. Next is an according to control systems. So one is the open loop control system and another one is the closed loop control system. What is the difference between open loop and closed loop is, in open loop there is no feedback. In closed loop the feedback is there. The applications of NC machine is frequently subjected to design change. When we compare to conventional machines, the design change, if you take a caption or a turret lathe, it is a simple multiple operation of the conventional machine tool. So if we want to change some design, we can't do it immediately. We have to do some of the procedures in order to change the shape. Whereas in the NC, if we change the tape, the instruction tape, if we want to change the instruction tape, it can change the operations or it can change the methods. So like that the advantage can be done. Next, cut down lead time in manufacturing. It cut down the lead time in manufacturing because the setting time is very much reduced. Precision quality parts can be manufactured, and disadvantage is not feasible for high production. So this is one of the advantage of CNC and DNC. For it is feasible for high production and high variety kind of components can be manufactured in CNCs as well as the DNCs. Now we will move through CNC machine. So function of CNC machine is machine tool control. In process compensation can be done. So in process compensation means if there is a tool wear, if there is a tool wear, the tool wear causes dimensional inaccuracy. Therefore, the compensation of the dimensions can be done in CNC machine tool. Improved programming and operating features and easy of diagnosis. If there is any problem in machine or a tool, the immediate feedback will be given and it will indicate where the problem is or origined. So like that, it can diagnose all the problems. Next, we are going to compare NC machine and CNC machine for the betterment of understanding. In NC machine, purely hardware based system, whereas in the CNC machine, hardware as well as the software based system. Here in the NC machine, tape is read again during the production of each part. Here, one time reading of the program. Yes, if I want to produce 100 parts in NC machine tool, the NC machine tool will read the tape 100 times. Whereas in the CNC, only one time is been readed, and we can set like a photocopy, like making of a Xerox. If I want to set, I want to produce 100 pieces. A one-time reading of the program, it will automatically do the 100 pieces. When we add the component is enough. See here in the NC machine tool, editable is not possible, whereas CNC editable of the program is possible. And NC machine, one punch card for one program. Yes, one punch card for one program. Here there is no punch card in CNC. And NC, there is no built-in memory. There is no built-in memory, whereas CNC, there is built-in memory. We can say hardly a 10 or 20 programs can be stored in the CNC machine itself. Yeah, and in the NC machine tool, there is no computer display, whereas in the CNC, computer display is there. And NC machine tool, no control on speed, feed, depth of cut, whereas in the CNC, there is a control of speed, feed, and depth of cut simultaneously. In NC machine tool, low and medium scale production can be used. For CNC, it is used for large scale production. In NC machine tool, jigs and fixtures can be used, and the CNC also jigs and fixtures can be used. In NC, it is having low productivity. In CNC, it is having high productivity. And compared to CNC, the NC produce less accurate parts. When we compare it to conventional, NC machine tool can produce more accurate parts. Whereas in the CNC is more accurate parts can be produced. Like that, CNC, NC and conventional. So decremental order of an accurate parts. Whereas in the DNC, it is like a CNC. The difference is a number of CNCs can be controlled by means of a single computer. So that is the thing. Therefore, CNC will produce more accurate part than NC as well as conventional machine, whereas NC produce a better part than conventional. So this is our understanding. So next is the DNC. So as I said earlier, the several machines can be controlled by means of on one computer, and here the flexibility to make improvement in such features can be done. And Cad Cam, it is a controlled by application softwares. We can say softwares. We can say the softwares having system software and application softwares, whereas in the Cad Cam is the application software. Okay, I hope you can understand what is meant by system software and what is meant by application software. If we install the Windows 7 or 10 or Linux, this is called as a system software. If you want to draw a diagram or if you want to make a modeling, we can use AutoCAD, Creo, NXCAD, CATIA, like that. So this is called as an application software. If we want to simulate, we can use EdgeCam, MasterCam, like that, CNC Pro Tools, like that we can be used. Or if we want to interface both the things, the Delmia kind of a thing can be used. And if we want to analyze the ANSYS, Nastron, Abacus, HyperWorks, or can be used. So these are all called the application softwares, whereas a system software is a one thing which operates the system. That is why it is called as an operating systems. So next is an adaptive control system, that is simply say it as an ACS. It is a logical extension of CNC system. It is a logical extension of CNC system. The calculation of the speed, feed, depth of cut can be done in adaptive control system. In the CNC's adaptive control system, in all CNC's, ACS plays a major role because the feedbacks and the speed, feed, depth of cut can be controlled simultaneously whenever it is needed, and whenever it is not needed can be controlled the system itself. So that is why the advantages of CNC is more. So now here we are move upon the advantages of ACS. First one, less intervention of operator. Less intervention of operator. Tool life can be increased. Increased production rate. Easier part programming. Easier part programming. So these are all the advantages of adaptive control systems. Next is a machining center. Machining center is a NC controlled machine tool. Simply, it is an NC controlled machine tool. Like boring, drilling, milling can be controlled by single machine using NC. In a single milling machine itself, we can put drilling, we can put boring, we can do milling operations too. The number of step up times and spend in setting and transportation between centers and machine time can be reduced by means of a machining center. Therefore, a single machine can produce all the things. The machining center will be like maybe a horizontal machining center or a vertical machining center based on the spindle position. Whether it is in the horizontal position, it is called as a horizontal machining center. If it is in the vertical position, it is called as a vertical machining center. VMC and HMC we can say. And these machining centers are being used for batch production. Batch production means decent amount of volume as well as decent amount of variety of parts can be manufactured. More variety and more parts also can be manufactured. So that is the purpose of machining centers. Next is a Cad Cam. In the CAD, the IGS, interactive computer graphics, plays a major role. What is meant by IGS? It is used for oriented system. The computer is employed to create, transform and display the data from in the form of pictures or symbols. If I am saying a rectangle in a CAD modeling software, it gives the rectangle how it is behaves in a two-dimensional view as well as the three-dimensional view, and the mosses, all the datas can be picturized. We can even rotate the rectangle. We can even make the rectangle. We can tilt the rectangle. All the things are been possible by means of an interactive computer graphics. That is a very important in CAD. Next is the CAM, a computer system used for plan, manage and control the operations. It can plan, can manage and it can control the operations. Direct or indirect computer interface for production resources. So here also the computer is needed to make and play the datas which are all available in the manufacturing systems. This is also been done. Next is a computer aided design. In the computer aided design, the product life cycle is very important. So the product life cycle is being postulated as a bathtub curve. So this is the bathtub curve for the every product is in y-axis and time is in x-axis. In every product, initially it when it coming to a market or a manufacturing or a designing, The product should be initially initiation stage. After that it can be growth like that and mature and a decline. Here what I am saying is, if I want to create a product, for an example, if I want to create a pin, we have a different types of pins available in the market. How we can do a new type of a pin? We go with the survey and we go with the model, and we are benchmarking several models, and those several models and initiation of creating models are in the initiation stage. Once we done all the benchmarking, all the initiations, we can go, the model can be drawn in the CAD model, and it can be like a growth stage. It can be in the growth. So when the product will come as a live product in this beginning of the maturity stage, and after that all the testing process and all the other aspects can be drawn and can be incorporated in the product. After that the manufacturing and marketing have been done here. The maturity stage, the manufacturing and production can be done, and it is going to the market, and it is for hitting the market and survey. Once the time goes on, every product have a decline stage, where if its trend is over, it will decline. So that is the stages in product life cycle. So it is like a bathtub. So we know that bathtub is like this. So this curve is the inverted bathtub. That is why it is called as a bathtub curve. Next is a CAD. CAD, with the aid of computer in creation and modification and analysis and optimization of design, is being done. As I said earlier, the CAD tools are AutoCAD, Creo, NX, uh, and CATIA are the some of the CAD tools. It is used for creating a model, modification, and analysis and optimization of the design can be done with an aid of a computer. With an aid of an computer. Next is a computer graphics. Computer graphics is used for transform or generating an image with the 2 dimension as well as 3 dimension. 2 dimension to 3 dimension transformation, translation, scaling, as well as the rotation. So this purpose the computer graphics has been used here. The next is the in the transformation, 2 dimension geometric transformation, we have a translation. Translation means moving of an object from one location to another location, or moving an object to the different location is called as a translation. The scaling is we know that in the scaling we can enlarge the component as well as reduce the component. Like that, enlarging and reducing scales are being done. That is called scaling. The rotation, view model from different directions. We are going to pivot a point, and according to the point, the CAD model can be rotated. Next is the coordinate system. We have three coordinate systems. One is model coordinate system. In the model coordinate, the model have their own coordinate. So the model is their own coordinate. In for each and every model, the coordinate is associated with the model. It is said to be a model coordinate system. Our old coordinate system, we have a default oriented coordinates. On the coordinates, the different kinds of models can be pasted. So the world coordinate system is the best example of AutoCAD drawings. So the coordinates can be used in the worldwide, and the components can be drawn anywhere in the sheet, and it can be maken as a different sheet. Whereas the model coordinate system The Creo and NX are using the model coordinate system. Next one is this screen coordinate system. 2D device dependent coordinate system. This is a two-dimensional devices dependent coordinate system that is called as a screen coordinate system. If we want to draw a simple model or a simple component, we can use screen coordinate system. In the computer screen itself having a coordinates of x and y, so that is why it is called as a screen coordinate system. Next is a viewing transformation. Translate the view in different point to origin of old coordinate system. It is called view transformation. Next, homogeneous coordinates. Homogeneous means same coordinate for all, whereas the Cartesian is the same coordinate, and homogeneous is the all components will have the same coordinates, whereas the Cartesian, it is a common coordinate is there. So that is have been explained here. Next is a solid model. In solid model, the 3-point arc or curves, the 3-point arc and curves have been given. So with the 3 points we can generate curve. Curve generation is we can say curve generation can be done by parametric derivatives as well as the geometric continuity. Here the curve generation, in every drafting, the curve generation is very important. For the curve generation we use two types of curves, that is spline curves as well as B-splines, that is called as a brazier curve. Brazier curve. In spline specification, it is a set of boundary condition. The set of boundary conditions to be needed matrix that characterize the splines, and it is functioning on geometric constraint, that is calculate position along the curve path. Cubic spline interpolation method is being followed, like as I mentioned in the curve. Next is a B-spline or brazier curve. The varying number of control points with varying locations can be done. So this is a parametric derivative. The parametric derivative means it is functioning on polynomial equation based on the geometric curve. We know the polynomial equation, that is a cube u cube a3 u cube plus a2 u square plus a1 u plus a naught. So that is the polynomial equation. For every position this can be done. So the what is the difference between brazier curve and spline curve is, brazier curve is smoother than splines or cubic splines curve because it uses higher order derivatives. Brazier curves uses higher order derivatives. The curves contains control points and higher order derivatives is very important in brazier curve. The curve passes through first and last control points, so that is very important. So next we are going to discuss about the Cnc codes, that is G code and M code. So G code is a proprietary function. What is meant by proprietary function? The machine tool position can be controlled, that is called G codes. Here we can say in G codes it starts from G00 to G97 I have given, and there is lot more. G256 codes can be used for numeric softwares. So G codes are can be used for FANUC as well as numeric softwares. The FANUC, most of the CNC machines uses FANUC. The most of the machine tools, machining centers using numerics. So the codes can be different. So the G and M are being common, but the codes are different. Some of the basic codes which is common to both FANUC and FANUC and numeric have been posted here. So in G00 it is a rapid transfers. G01 linear interpolation, G02 circular interpolation clockwise, G03 circular interpolation counterclockwise, G04 dwell, G10 input cutter of offset data, G17 selection of x and y plane in milling, G18 xz plane, G19 YZ plane, G20 input specified value in inches, G21 input in millimeter, G28 return to home position or reference point, G32 thread cutting in turning, G40 cannot cycle, cancel offset compensation, G41 cutter offset compensation of part surface in left part surface. In G42 it is cutter offset compensation in right of the part surface. G50 specify location of coordinate axis and system in some lathe. G72 74 it is cannot cycles. G92 it is used for milling and drilling machine. G94 feet per minute in milling and drilling machine. G98 feet per minute in turning. G90 absolute coordinate, G91 incremental coordinate, G94 feet per minute, G95 feet per revolution, G97 constant speed, and G98 initial position return. Like that, the miscellaneous function M codes, or it supports the machining operation. That is called, it is called miscellaneous functions, like starting the program, stopping the program, spindle rotate, coolant supply. Like that it can be done. First, M00 program stop, M01 optional program start, M2 machine stop, M3 start spindle in clockwise direction, M4 start spindle in counterclockwise direction, M5 spindle stop, M6 tool change, M7 turn cutting fluid on, cutting fluid is on, M8 cutting fluid is on, M9 turn off the cutting fluid, M10 automatic clamping of fixture in machine slides, M11 automatic unclamping, M13 start spindle clockwise cutting fluid on, M14 start spindle counterclockwise cutting fluid on, M17 spindle and cutting fluid off, M19 turn spindle off at oriented position, M30 end of the program, machine stop and rewind the program. So like that, the G codes or and the M codes have been for controls the computer. This coding only the machining have been done. The next one is the jigs and fixtures. You have to know the jigs and fixtures. These points are very important for jigs and fixtures. Generally, jig is a tool guiding device and it also holds work. And a fixture is a work holding device. You have to understand these words very finitely. Jig is a tool guiding device and also it holds the work, whereas fixture is a work holding device. It won't guide the tool. And principle of location, it is having 6 pins or is being used for 9 degree of freedom or fixture. 9 degree of freedom on fixture. What I am saying, the 9 degree of freedom, we have a positive x, positive y, negative y, and a positive z and a negative z, and also rotation, clockwise rotation in x-axis and a clockwise direction in y-axis, clockwise direction in z-axis. So that is called 9 degree of freedom. We have a 6 linear and a 3 rotary can be arrested in the principle of location. Generally speaking, we have a 12 degree of freedom in jigs and fixtures. Some of the books you can see a 12 degree of freedom, like a positive x, positive y, positive z, negative x, negative y, negative z, and the clockwise rotation of x, anti-clockwise rotation of x, clockwise rotation of y, anti-clockwise rotation of y, clockwise rotation of z, and anti-clockwise rotation of z have been uh, given as a 12 degree of freedom. Here the 6 pins are being used. In the first 3 pin, the 5 motions have been arrested. In the next 2 pin, 3 motions have been arrested, and last 1 pin, 1 motion is being arrested. That is why the 6 pins are enough for making 9 degree of freedom, for arresting 9 degree of freedom on the fixture. So with this information, I'm going to stop the Cad Cam session. I hope I have given enough knowledge. Whatever I am knowing, I have given to you. If you have any doubts, please let me know in the comment section. I will put another video for your doubts. So until, bye bye from Santhosh, and thank you all. Thank you for patient listening.